Hey everyone, we're going to try something a little different today. We've decided to do some answers to your questions on a video type format like this. So we are hoping to eventually do this as a live webinar, but we wanted to just kind of test this out and see how it works just on a recorded video format right now. So when you send us your questions on the question line or in the forum or other things like that through the course platform, we want to be able to answer them to you in some sort of video format. I know that we answer typically to you in email format or text, but I think this will be very helpful for two reasons. One, it's easier to show things on video, and two, it's very helpful for everyone else because everyone might have the same question. People may be getting stuck on this, so your question can help everyone else. That's why we wanted to answer these publicly and show you just the best way to kind of think about these things so that everyone else who may have questions as well can get their questions answered. Now, this is going to be a little rough. We're still home with the quarantine and everything like that going on. So you may hear my dog barking, or you may hear my son screaming, or something fun like that. Please ignore that. But we are going to be discussing 4 questions that we received on our question line, just to kind of show you and go through how this type of thing will work. So let's get started. So moving forward, we got a couple questions from Andrew. Actually, we get this type of thing a lot where someone asks a question and then they kind of answer it themselves and see if they're correct. So we wanted to go over this, but this is a question about total runout here. So Andrew is asking, based on our little illustration that we have on our GD&T wall chart, if the size and the tolerance of the shaft with runout is 1 inch plus or minus 0.03 inches, does that mean the tolerance zone for the feature size is the same tolerance zone for the total runout, 2 concentric cylinders? Really what this is asking is, does rule number 1 take over here if we had a size tolerance tighter than the total runout? Continues to ask, by controlling these is further constraining the size since the total runout applies RFS, and all points must lie within the runout tolerance zone. So really, what takes over? Is it rule number 1 or is it runout when it comes to the form control here? So if the runout was increased and the size tolerance was still very tight, how would this affect the part? And then Andrew replied to us again, and again, this happens a lot with people, and we love it when you do this because it helps to know that you're digging into the standards and kind of looking into this. Andrew put a figure from the Y14.5 2018, which is a nice new helpful diagram that was added in the 2018 standard, where they talk about the total runout or runout and what is being controlled and kind of what the hierarchy is as you go down. So what he found out was, if reading this correctly, when the size tolerance, plus or minus 0.5 in the case above, is the same as the total runout zone, total runout controls all the potential variables, and that is correct. When runout tolerance zone is larger than the size tolerance, it controls only location and orientation in this case too, but it would be location and orientation. And for the condition not treated above, if the runout tolerance were smaller than the size tolerance, it would be a refinement to location, orientation, and form, but would not control size. And that assessment is accurate. Yes, Andrew, you got that right. Really, the only thing here is that it will control orientation as well. Rule number 1, remember, does not control L or O, or location or orientation. It only controls the physical size and form of the feature. So for example, if I ripped off the feature and had it floating around in free space, that is what the rule number 1 will actually control. So it does not control how it relates to other features or other datums on your part. So just to break this down once more, really we have, if you remember from our sloth lesson in our fundamentals course, we have this. We have size, location, orientation, and form. Runout is something, and I'm going to get my pen real quick. All right, got my pen here. So runout is a very different type of symbol, runout and total runout. The reason is typically a symbol like position will be controlling the location and the orientation of something. Size tolerances control just the size and form, but usually there's not much crossover. The combination symbols, as we call them, are really like profile, which technically can control all of these. But runout and total runout are kind of strange, and they're strange in the sense that they control these three elements, or they can control these three elements. If they only controlled location and orientation, that would be position, right? That's the position symbol. We can control not only, if we have to datum's ABC, we're not only controlling the locations from maybe the sides of our part, but we're also controlling the perpendicularity to the face of the part, or whatever we're using as the perpendicular datum. So position controls location and orientation. It's that go-to symbol. Now, runout is bringing in form into this. And the reason we do that with runout is because it's easier on a lathe to control all three of these than actually breaking them up. So when we are controlling total runout and runout, if you remember from our lessons, you can control them using just a simple dial indicator on a lathe as it's rotating. So that's why runout is commonly used. But the question is, if we had a tight size tolerance on our part, what does that mean in terms of the form being controlled as well? And Andrew, it looks like you've already figured this out, and great job doing that. But really, the size, rule number one, takes over in this case. So let's say that we had, in this case, runout of 0.1, and we had some sort of size tolerance of plus or minus 0.05. So let me actually make that tighter. Let's do 0.025. So now we have a total size tolerance here of 0.05, right? That is what is controlling our size and our form. So if that's on a diameter, remember we have that rule number one where the MMC could never cross the upper limit, whatever this is. Let's say this is 10 plus or minus 0.025. Well, the surface could never cross out of 10.025, right? That is what the hard limit is on this case. So if you had a go gauge, for example, just a ring or a sleeve that you put over a cylinder, that was set at 10.025, that sleeve should be able to go over the part. Now, we're not controlling what angle that is at, what angle the cylinder is relating to the rest of the part, or relating where the orientation is, but just that physical cylinder size needs to fit within that rule number one, and that is always the case. So let's move over here because I built a little bit of the hierarchy here. This is also a handout in the sloth lesson in the fundamentals course. But you can see here that in this hierarchy here that we have size and form being controlled by the size tolerance. So let's say we had our cylinder here like that, and then, it's attached to some other cylinder on the rest of the part. So this is going to be our datum A. This is what we're relating the location and orientation to, but we're just controlling this in terms of the size tolerance. So 10 plus or minus 0.25 as we had before. So sorry for my handwriting. All right, that works there. So the MMC size, the largest size this cylinder could be, would be that hard limit at 10.025. And no matter how loose the runout tolerance is, so let's say that we have the runout tolerance here as well of 0.1 there. So if we have the runout tolerance of 0.1, then that is not going to be controlling our size at all. Runout can never control the size. The size of this cylinder here can float in and out within whatever size tolerance this is. So if it was looser, no matter what, the runout would never be able to control the size. Same with if it's tighter. So no matter what, we're doing that. The real question is the circularity, or the form of this. So with the runout being looser than the size tolerance here, The runout is actually not controlling the circularity. The circularity has to live within this tolerance here, the 10 plus or minus 0.025. Remember, it can't exceed. So if it was like if it was a triangular lobe shape like that, no matter what, we could not break that barrier of 10.025. And then every 2-point measurement, due to rule number 1, would have to be larger than 19.975, right? So it has to live within that. That is controlling the size and the form. In this case, is rule number 1. The runout, though, the 0.1, is controlling now really this axis of 0.1. So this 0.1 is being controlled by the runout. Now here's the tricky thing about this. Let's say that the form of this part went all the way up to the max. So due to rule number 1, the max circularity error we could have here is 0.05 in this case. So if we had a dial indicator on here and we had that 0.05 of error, as we rotated it, the runout measurement would be picking that up. So that is contributing to this 0.1. So that means that our position tolerance would need to basically equal the remaining amount of that, because really what runout is it's form plus location plus orientation error all have to be built in within this 0.1. So it will still contribute to that runout measurement. But in terms of absolute limits and what we're actually controlling here, if this, let's say, was a perfectly round cylinder, this runout control would be essentially a position control of 0.1 and would only be controlling the location and orientation. So the rule of thumb is when using runout, just to kind of simplify this all. It's just actually what Andrew listed in his email. If the runout is, so if the runout here is equal to or tighter than the size tolerance. So let's say that we had a size tolerance. So in this case, we have a total size tolerance of 0.05. Let's say the runout tolerance was 0.01. So it's much tighter. In that case, then yes, it is controlling all LOF. It is all of that is built within there. The only thing the size tolerance is controlling is the S portion of slough. However, if we get to a point where we had the example before, where we had the 0.1, so now the runout tolerance is twice as large as the size tolerance. Well, now the size tolerance is what is picking up that limit to the form. And no longer is runout capturing that. It's really acting as a position tolerance. The caveat to that was what I mentioned earlier, which is that dial indicator will still pick up this, and it may still contribute to that tolerance in your measurement. But when it comes from a design control, the form can never exceed that size tolerance, and then the location and orientation could never exceed your runout tolerance. So I know this is a little messy, so I wanted to just simplify this at the end here, where if your runout tolerance is larger, if it's more open than your size, if your size tolerance is tighter, then runout really is only controlling that L and the O because the size tolerance, due to rule number 1, is picking it up. However, if your size tolerance is looser but runout is tighter, well, now runout is picking up all three of these things: the circularity error, the orientation, and the location here. The size tolerance is only controlling that because rule number 1 is overridden because runout is tighter. So this one's a little confusing, but let me know if you have any extra clarifications or things that you need with this. Runout is a very confusing thing to do on paper and in design. However, it's still a very great control to use because it is very easy to do in inspection. It's very easy to use right on the machine. So machinists love it, inspectors love it. It's just important from a design standpoint that we really understand what we're applying here and what we're controlling. All right, great. Let's move on to the next question here. We got a question here, and this was being asked. I believe this question was from, let me pull this up.